Hello and a warm welcome back. So I've insussed out that we're going to use a valve regulated anode power supply. As mentioned, I need to think about where everything goes, and this is a very rough layout of the proposed front panel. And we need to monitor the heater voltage, the anode voltage, the bias voltage, the screen voltage, the anode current times 2, because we need to hopefully test dual triodes. But in the past what I've done is to test one side and then the other, which is not very efficient way of doing things. And then the other thing, which is the question mark, which is the GM, we'll get to that later. And so this is a very rough sort of scribble of what I'm sort of thinking. I'm going to use the patch panel because switches obviously just takes loads more room. I'm not going to use panel meters because they're not accurate enough. And so this is the sort of thing we've got. So usually when I test a valve, bring up the heater voltage, and then obviously if we've got a variable variable heater voltage, then we've got to bring it up to 6.3 volts or whatever. Next, set the bias, because without bias, the valve can just run away and go bang. Well, you don't go bang, but you understand what I mean. If we're testing the pentode, we need to then set the screen, then the anode, etc. So this is a rough layout of what I am going to do. Next, I need to go and fettle the panel. Right, it's a grand day out this morning. Where are we? About May the 7th ish, something like that. And England in May on a sunny day obviously is really quite nice. Oh, I ain't got my grandma jumpers on. Anyway, where were we? I've roughed out the piece of aluminium, I think it's 2mm alley sheet for the top of the valve tester, and so all I did was just cut it with an angle grinder by eye. So now I need to get rid of all the burrs and sort of square it up a bit, and I just do that with 2 files. This is a really sort of rough file, this is a bit of a rough file. You don't want a fine file with alley, because like I say, it's a sort of cheese, so it bungs your files up if you're not careful. And I have nothing as fancy as a table, I just got an old stool. So let's just get rid of these old burrs, for a start. Yeah, so there's a lot more of that to go. I'll come back in a bit when I finish, because it's just going to be boring watching me doing this. That's the bit of metal deburred. So next it's just a matter of looking to find the side that is mostly square and then working off that, sort of use that as my datum point. You can see there, that's where the mill or wherever made the bit of sheet, rolled it, that's square. So next I'll square either this side up or this side up, and then do this end last. I don't know if you can see, we're in a bit of shade here, the cut isn't brilliant, oops, bit on the cock, but with that big square file it takes a lot off, and I can soon get that squared up. I've got the sides and everything mostly square, although it's nowhere near perfect. If this was for an amplifier build, I would take a lot more time to get it bang on, but as I want to make a sort of speedy job on this valve tester, I'm not bothered if it's just out by a few mil here and there. Got the holes drilled to locate it on the actual valve tester chassis, and then now I need to start thinking about what goes where. But first of all, we'll start with the basic on off switch, which will go there somewhere like that. So to locate it, what I've done, so I've not got much room on the bench at the moment because I've got a lot of things going off. To locate it, I've marked out the confines of the actual chassis box thing itself, so I can't go over there, there, etc. I've also marked out halfway and all the rest of it. So this switch here, the on off switch, as long as it goes somewhere about there, we should be grand. To do that, to help sight it properly, I'll take some measurements using this digital vernier. However, for a long time I used to use this old sort of mechanical, very simple mechanical one, and just rulers and things, so you can do it with very little tools. So the width is pretty simple, 21.86. This leads me to believe that this is probably a, this leads me to believe that this is an imperial sized switch, 22.17, yeah. I think if we have a look, that's about 3/4 of an inch. What is it now? It's a bit over that, isn't it? Ooh, okay. Yeah, of course, it's 7/8 of an inch. This measurement from here to here is a little bit more tricky because you got these locating tabs, and when it's pushed into the slot on this face, they will squeeze in and lock it tight. So we've sort of got to get quite a tricky measurement, which is these wings pressed in a bit, and we've got 30 mil. So we'll go for that, 7/8 of an inch wide and about 30 mil. We can always adjust afterwards when we've, you know, made a big hole. Well, I made a bit of a, well, I made a lot of a pig's ear of that hole there. Got me measurements completely wrong. Hopefully you can see that. Made it way too long this way, so I've had to make up a bodge plate that will sit behind like that and keep the switch in place. I could make it, I could file it out and everything so it fills in that space there, but that'd be a lot of work, and as mentioned previously, I want to get this done, I want to get this job done quick. So it's very easy to do. I must have got that, what, too big by about a couple of sixteenths. What's a couple of sixteenths of 32th? Oh, I don't know, a good few mil. So big cock up. Never mind, onwards and upwards. To cut the hole for the patch panel, we need about a 3-inch diameter circle cut out. So I'm going to mark that off and then chain drill it the same as I did for the hole of the on-off switch. But hopefully I'll make this a bit more accurate and make a bit of a better job of it. Right, so that's how it'll sit. We'll centre it somewhere about there. And I'm just gonna rough mark there, so that'll give us our centre. I've already measured it. As mentioned, we want a 3-inch diameter, so we want 1.5 inch. To set the compass to. Oh, that's not very. Right, and that's just moved. Well, I cocked that up, didn't I? Oh dear. That's about 1/4 done. I don't bother centre punching it. Forgive the noise. Start the first one off. But really hard to do with this bloody camera in the way. So if I'm off there, I don't know if you can see, I'm off from my line. I'll walk the drill towards it. Try and demonstrate round the camera without bumping into the door. Now obviously flicked up there, so hope you get the idea. Yeah, that's the problem with this sort of approach. Obviously you sort of can go up skittering across, which is ruin the finish on the thing. So ideally, if this was the face of the valve tester thing, I'd have done it on the back. So all something to think about. Right, that's all the holes drilled. So next, what I'll use is this really old and tired Makita drill. One moment. Are you gonna focus, you bastard? No, not you. Camera. The reason I use this old Makita, it's a little bit lighter than the Bosch mains drill, and it has less power. And it's obviously you don't want like a big powerful drill trying to do this sort of bit. Again, hard doing it round the camera. Right. And that's the only problem with this keyless chuck, it's crap. Right. Oh, can you see? Get the idea? You're sort of using it as a... I don't know, what are you using it as? I have no idea. My words of description fail me. And it's really hard to do this properly round the fecking camera. So basically you just go round, making the holes bigger, you know, jiggling the drill from side to side until we get to the other side. If I don't see you no more in this world, I'll see you on the other side. Right, now that's chased out. It might knock out, but I don't think so. So, try and get your framing right. If you drilled like holes a little bit too far apart and they're not all quite linked up, just get a sharp screwdriver, #1 hammer, gentle, if you whack it too hard you'll deform the plate. Right, see if that knocks out now, yeah? And there we go. We got a nice, lovely, clean circle knot. And then as previous, which you've seen me doing, using a very coarse file to clean that up. Doesn't matter that it's square, obviously it would be better if it were round, but to do this I want something coarse and just to take off the, you know, the worst of it. So as you can see, just by that little bit of filing, we're starting to get rid of all the jagged edges. Now I've got the worst off with that big coarse file. I shall use this slightly less coarse file, which has also got a round profile, to clean that up down to the line. There, that's more or less done. Still a bit rough, but I'll just finish it off with some wet and dry. And as you can see from the finish, you get a really nice finish. That took about 20 minutes. It took less if I hadn't been filming. Onwards and upwards. Next, finally, tidy up, because those filings there, they are a nightmare. They'll stick to your socks, get in your underpants, all sorts of places which you didn't even know existed. So get the buggers swept up and we'll be ready for the next bit. Well, here's the progress so far. Next, I think I need to move on to the actual circuitry, transformers and all the rest of it inside the valve tester before I start laying out the various controls, because obviously it's no good having a heater supply down here, say, and a potentiometer to adjust that heater supply all the way over there. So we need to get the bits inside sorted out so we can then lay out the top. So a while back, a few videos back, before I started hacking the top plate out and all the rest of it, this is where I've got the power transformer mounted. I got the mains fuse in there mounted, and then realised I'd fucked up because I didn't put the on off switch on there, although strictly speaking I could have got away with that one, because I can just use my, you know, control panel thingy doodah there. So in there, and there you can see 4 fuses, which should correspond to the 240, the 260, the heater supply and the bias supply. Strictly speaking, I didn't need these big long fuses. I tend to use these longer fuses. What are they, about 1.5 inches, something like that, for things where I've got DC. If you're trying to fuse DC, you need a longer fuse. That's how I think of it anyway, because the AC current is going choop 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 choop. There is less chance for a big arc developing within a fuse. I mean, yeah, you can use like what do you call it, HRC fuses, high rupture capacity fuses and all the rest of it, but that gets expensive. So anyway, I digress. So that's in there, and then next we need to think about transformers and things. With me using a big 6080 as the series pass element in a anode supply, this transformer I don't think will be able to supply that. Well, I know it won't. I didn't wind it for that. So I've got another RS high grade filament transformer which will supply about 2.5 amps for the 6080, and it's good because then that's floating. Because the 6080 cathodes are sitting at a high potential, i.e. 360 volts, then we have to watch out for our heater cathode voltage max spec that's on the data sheet. So ideally we ought to float the heater supply up at about, I don't know, 200, 250, maybe more volts, although the 6080s are pretty rugged valves and the heater cathode insulation is designed with that aspect in mind. Right, I have some hard decisions I need to make. They're not hard, but they need to be made now before I go any further. The first one is, do I mount the valves for the anode power supply here, sort of thing? So there's going to be a, is that going to stay there? It's going to be one of them, and instead of using a Zener I'm going to use a voltage regulator valve, so a little B7A08, I can't remember what it is off the top of my head. So do I mount them there? However, if I mount them there, because this valve tester isn't, there's nowhere to put it where it can just sit there and all the rest of it, so it'll probably get stuck up the top there on top of all this junk. Which means that the valves will need, if I mount them there, which means the valves will need to be taken out every time after use, put somewhere, and then reinstalled every time you use it. Or do I put them inside? As you can see, they won't take up that. I can make like a little sort of sub-assembly, and all the circuitry and everything will fit, say, something about that much space. But then we've got the problem of heat. So if we put them inside, then we've therefore got to think about some form of cooling. Well, I've got this lovely big old, I think it's a mains voltage fan, which is, I think, will probably fit there. And I think there was originally there was a fan in this thing, whatever it was, when it started its life. That's too big though, I think, for the job. Or we could use like a, you know, a sort of PC fan. I've got quite a few of these, something like that. But we've also, regards cooling, we've got this is just the heatsink that I used last time for the series pass transistors for the DC power supply. I'm going to do it obviously a little bit better than I made of this job here. So that's got to sort of fit in there, and then we've got this other transformer that fits in there. And then the other thing is, what I'm thinking of is, like in the past I've had to work on this periodically to change MOSFETs and all the rest of it because they blew. And so this front panel, I'll try and pull you back a bit. This front panel is secured by either, you know, well, it should be secured by 6 bolts. But if you come to work on it, then you've sort of got to prop it open. So what I've done in the past, I'll try and zoom you in. Is drop a screwdriver in like that and then sort of prop it up, but you can see how precarious that is. So when I go to town today or tomorrow, I'm going to see if I can get some little brass hinges whereby that can hinge up, and then I don't know, just use a stick or whatever to prop it up, or something a bit more fancier. So there's that to take into account as well. Lots of design decisions to make, and you'll find that you have this if you ever make anything using, you know, found cases, modifying cases to fit your projects, whether it be an amplifier, a valve tester or whatever. You always have these decisions to make, layout, where things go. Then you have to take into consideration the heat that is generated if you're using valves or transistors or whatever. All of these things need thinking about. So I'm going to have a ponder about that and get back to you in a little while. Oakley dokley. I was getting all sort of bent out of shape trying to make too many decisions at once. So what I'm going to do, I'm going to concentrate on one thing at one time, and that is first of all the anode, variable anode supply, valve regulated anode supply. And so what I'm going to do is get this schematic, figure out like a point to point layout. I'm not going to do it on a PCB, and then maybe mount it all up on just a small sort of plate or something. And then when I figured that out, I will figure where in or out of the valve tester it shall go. E-I-E-I-O. So I'm just about to draw like a point-to-point diagram of the anode valve regulated power supply, and then I was looking at using a valve voltage reference to give us about 75 volts. All the ones I've got, like 85A2s and things like that, are about 100 volts. No sort of 75 volt ones. So we've got lots of neons. So I've just sort of been through my drawer of neons. Got some quite old ones that are getting really hard to find now. But I do have a lot of these which I'm not quite sure what they are. Thing is with neons though, a bit like a Zener, they only need like a few hundred microamps to function. Unlike a Zener, they have a striking voltage, so they need sort of a higher voltage to switch on than their actual voltage that they clamp at. So for instance, this neon here has a clamping voltage, let's call it, of about 60 volts, but it might need like 110 volts to strike. Right, I've fettled a plate to mount the octal socket and the B9 socket. Not quite sure what happened with the chassis punch there, but it doesn't matter. It's nobody's gonna see it, so don't give them monkeys. So now I've basically got to wire it all up. Next I need to orientate these 2 valve bases before I drill the mounting holes, such that, say for instance, we've got pin 5 of the octal here going to pin 6 of the B9A. So where do I orientate that? Pin 6 should be, where are we? 1, 2, 3, 4, like that. So I'm going to have a think about that, drill the holes, and then let's get this bugger built. That's the 2 valve bases mounted, a couple of standoff temporarily in place. I'm not quite sure whether I'll use them, they're a bit high, and a simple bus bar as our ground. And then next I can start wiring it up. I've got the 2 triodes strapped in parallel with appropriate insulated wires. I've got the heaters connected together, so they just need connecting up to a transformer or whatever. And then now hopefully we can populate it and bung some resistors and things to make it work. Well, as you may hear, it's a little bit rainy today. This being England, should I say, it's the rainy season, which sort of goes from about January to December. Well, it does seem to be this year anyway, but still, folk, what the 3 cars in the garage, 50 pairs of shoes, and God knows all the peripheries and fripperies. So something's got to give. It's Mother Earth just trying to cool things down, maybe, I don't know. Anyway, back to electronics, back to the safe, warm world of electronics. As you can see, I made a bit more progress on the anode, valve regulated anode power supply. As you can see, most of the components are there. There's a few leads left long and a few untidy bits, and that's because it's part experimental. This is where our adjusting potentiometer will go, and that will go, let me just drop you down a bit. That will go down in there. Got a little fan there, was it a 4-inch fan to keep things cool. And then to supply all that, I've got loads of these. I used to have about 100 of the damn things, but they're very good resist. They are very good capacitors, but to get like a working voltage we need to stack them in series, but because these are 700 microfarad, we connect them in series, we get 350 microfarads with a 500 volt rating. I've been into the shed, out into the rain, and found a handy dandy nifty 2 capacitor mounting thing that will go in there, and then I'm gonna just stick a bridge rectifier somewhere on there, which will come from the mains transformer through a fuse, obviously. Well, there are the capacitors all mounted, and because we're putting these in series, they will need equalizing resistors across them, and the equalizing resistors will also serve as bleeder resistors. I have loads of new resistors, but all these resistors that I've used in the past to projects and things, I like to try and use them up. I hate waste. So I've just got a couple of 180k resistors across that I've just picked out there. As far as I know, the blue ones mean sort of high voltage, so they'll do, and I've used them on far higher voltage circuits with no problems, so we'll try those. I'm not just gonna bodge them on, I'm gonna make sure the leads because like on old resistors like this, new old stock resistors, the plating gets a bit tarnished, so I like to clean them up just with the back of a knife, and then I shall make sure they've got a nice pleasing curve to them just by using that screwdriver trick that I showed in the past, and I'll get those on. That's one of the resistor leads formed and just hanging loosely in there, and because like I have other connections to make, I shall just tack them in at this point, and hopefully it won't drop off while I'm soldering it. I'd already pre-tinned the capacitor, so that's one in, and then the other one I shall do the same. Clean the leads up. I've already already done that. I'd already tried to straighten most, some of the lead out. I just like things to look right. And those are both facing in the same way. I just think it's nice to just take pride of your work. And I'm just using a old pointed screwdriver just to bend them over. Again, it's hard doing this through the camera. Alright, you've got to go back down again. And because they need to join, this capacitor needs to join this one, rather than cut that lead off, I'm just wondering whether it can like go over there a bit. Not quite, will it? Okay, we'll use something else. We'll scrub that. Put it off there. And again, as I've mentioned quite a few times, I'm not a big fan of bending component leads round tags. Really hard to do this is through this camera. Pardon my French. But I know I don't do a lot of close camera work sort of stuff. Yeah. I'm not happy with that. Let me do this off camera because it's really hard to do this round a, yeah, you know what the score is. That's the rectifier capacitor combo done. I'll try to do it as neat as possible. I did think about, doing it on a PCB, but this is could have been the quickest way of doing it. However, the asymmetry of this here and that there is not pleasing. Looks better from that angle. I mean, it'll all work and everything, but you get very little chance to use your creativity with electronics, so any little metal bending or whatever. Yeah, I've got the anode power supply lashed up. This is the adjustment pot. I've just tested the voltage. At the moment I am powering all this up with bench power supplies so that I have some control over the current going in. I have double checked, triple checked all my work, make sure all the connections or the pins are right, but I still may have something wrong. This meter here will check our voltage reference. This here is the output of the regulator circuit. I've got a 3K9 power resistor on the output just for a bit of a load. Heater's on, let's crank it up. Thank you goodness for that, I didn't think it was going to work. £200 going in. Right, we need a bit more voltage. Oops. Right, it's my power supply is current limiting it. Ooh, you bastard. I think I may have something wrong because my big high voltage power supply is not happy at all. I'll have to recheck things before things go bang. Uno momento. That's why bench power supplies, current limited bench power supplies, are invaluable. If I'd have just whacked that on with the actual transformer and power supply in the valve tester, we might have had mega smoke. Right, well, something's pulling a lot of current. What is pulling a lot of current? Okay, well, the circuit's behaving itself at 300 volts. I'll just spin you around. The voltage reference says it is at 60 volts, and we've got an output of 280 volts, and we have 300 volts going in. I can only think that I had a short somehow with my lash up. That's everything wired in, some of it's temporary. The valve regulated power supply is in there. I've got a pot here temporarily clamped in this vise that is adjustable, what do you call it, to adjust the voltage. Got a 3K9 power resistor as a temporary load. Let's bung the bugger on. This meter here, leaning precariously, is reading the voltage across the load. Take a little while to come up because it's valves. Right, 323 volts. Just going to turn the potentiometer. I can adjust that. Let's try and adjust that to, right, because it's a one-turn pot, obviously I've not got really good resolution, but when it's on the actual, oh, okay, that's not too bad. 300 volts. Whack it right down. 163. It was a little bit different earlier on, but it's only a temporary lash up, so everything's working. Let me kill that. So that has taken quite a little bit longer than I anticipated, but never mind. You've got to try and do the job right. Lots more work to do. Other power supplies to work, other power supplies to fettle, but that's the most difficult one sorted out. Bit of a long video, I'm afraid, because there was quite a bit of fettling of components and what have you. Most of the donkey work's done. Thank you very much for watching. Take care of yourselves. Ta-ra for now.